Hey everybody, this is part 2 of my attempt to build a Raspberry Pi based screen for our UniFi cameras. If you remember last time, we got the display, touch, and power over Ethernet working, basically booting to a full desktop. But that's not what I want. I'm aiming for direct RTSP to the frame buffer. No window manager, no desktop environment, no bloat, just video. That meant wrestling with initramfs, systemd, and early boot weirdness. At one point, the FBI even gets involved. But does it actually work? Hey everyone, this is the second part of my attempt to build a screen for the UniFi cameras in our house using a Raspberry Pi and a display I bought off AliExpress. Last time we got the screen working, so basically a full desktop system, but that's not really what we want to do in the end. What we want to do is stream the cameras directly to this without all of the desktop nonsense in between. I have the screen set up again. I'm actually not using PoE power this time. We're just running the screen off USB power. I did have it set up here originally with PoE, but it turns out that the UniFi Wi-Fi adapter that provides PoE to the screen and the Raspberry Pi, the one that I have in my office, is unfortunately not powerful enough to power this screen. Right now I'm just going to USB power it. This won't be a problem when I actually install the screen because I'll have a direct connection to the switch that will provide PoE power to it. So that's not going to be an issue when we actually install this. We have the desktop up and running here. And what we're going to do is try and get something decoding on the screen. We're going to be using something called gstreamer. And gstreamer is a command line utility that lets you pull together graphs of video processing units, whatever they happen to be. They're very, very simple units. You have to chain them together, a lot of them usually, to do something interesting. But it basically allows us low-level hardware access to this Raspberry Pi. Because gstreamer is a little bit complicated, I need to pull up a little cheat sheet of all the different gstreamer. I think, to be honest, I can't remember what these are called. I guess they're called video elements. So what we want to do is just display some color bars on this screen. So we have the desktop running. We're going to try and use this video test source. What you have to do is basically build a pipeline like this. So we use gst launch-e, and then we say video test source. And this is not going to work because we actually have to sync it somewhere. So what we do is we add a sync. And here we're going to try FB dev sync. So FB dev sync is the frame buffer on the device, which is currently displaying the Raspberry Pi desktop. If we actually try to run this, we can actually see that it runs, but we're not seeing the frame buffer. So let's get ourselves out of the graphical environment and into the multi-user environment, which is basically just the text console running on top of the frame buffer. We do that with system control. So sudo system control. And we want to isolate to multi-user target. And you can see, okay, we're out of the graphical environment and we're in the frame buffer. Now, I don't think the camera here is good enough to show you, but little tiny blinking cursor here in the top corner. And this is basically the text console. The other thing we want to do here is actually disable this text console because the text console has taken over the frame buffer. Technically, you don't have to disable it. Actually, you know what? Let's just show this. So I'm going to run this video test source and pipe it to the frame buffer device. And you can see we have some color bars here, but we still have a blinking cursor in the top corner there. I'm going to kill that. It doesn't actually clear the color bars. This is just writing directly to the frame buffer, so the text console has no idea what's going on. What we want to do is we actually want to unbind this virtual terminal. So we can actually do that here. I figured this out earlier. So you just echo an empty string to this vtcon1, and when we do that, the blinking cursor is effectively gone, and you should not see it in this top corner anymore. And if we want to clear this, we can literally just write zeros to the frame buffer. And now the frame buffer is blank. We can do whatever we want here. So now we've got frame buffer access. This is working. This allows us to directly write stuff to the frame buffer. The next thing we want to do is try and display the RTSP stream of the camera on the screen. So RTSP is basically a real-time streaming protocol that a lot of these cameras use. They added this support in UniFi, I think a couple of years ago, which basically allows you to integrate these cameras into whatever system you want that supports RTSP. So what I did is I went into the UniFi console and I copied the camera's RTSP access URL. So what we can do here is see this is the camera's access stream URL. Now, one of the things here is that this is an RTSP URL, which is a secure URL. And if we try to pass this into gstreamer, we get an error here basically saying could not open the resource for reading and writing. Now, what's on trial and error, I determined that we actually have to use the non-secure version of this. This wasn't actually documented anywhere. I kind of had to play around with it, but it turns out the UniFi cameras actually do support RTSP without any security whatsoever. After a little bit of research, it turns out that the right codec we want to use is actually this very cryptically named V4L2 H264 DEC. So this is the Raspberry Pi hardware H264 decoder. And a lot of this gstreamer stuff, I have had some experience with it in the past. I ran some experiments way back where I had a non-UniFi camera that I wanted to stream video to a WebRTC stream. So basically have a video stream from this webcam anywhere in the world. I previously experimented a bit with this. I have this repo on GitHub, which shows how I did this before. And I used gstreamer for it. Unfortunately, gstreamer is a little bit complicated, and I always have to research and Google exactly how to set up these pipelines. But if you're curious how to do streaming in that way, you can take a look at this project and it'll show you at least a sample pipeline. Probably it's going to have to be updated for the more modern gstreamer and more modern Raspberry Pi setup, but the concept should be the same. So what we have here now is the pipeline with so the dpayloader, H264 parser, the actual decoder, and then the frame buffer sync. So if I run this, hopefully we should get a camera on screen. And there we go. Okay, great. So now we have a camera rendering, and it looks like it's somewhat real time. I'm not sure exactly how real time this is, but yeah, we can see the leaves moving. That's great. Okay, so gstreamer is basically able to get us the live stream from that UniFi camera. Let's try and have two side-by-side streams. Let's see if that works. I'm going to retrieve a second stream URL. So that is the basement camera, but let's try the backdoor camera. This is the URL for the backdoor camera. And again, change it so it's no longer RTSP. Now we should have the other camera working. Okay, perfect. So now we have two URLs. We know that they work independently. Let's see if we can decode these together. What we want to do here is actually create a video mixer. Now, I was trying to set this up to use the KMS setup directly. KMS stands for the kernel mode setting, and it's what all of the Linux kernels, all the Linux distributions are using now for doing on-screen compositing. Basically, it manages all these hardware layers for you in a more generic way that just works on any device. I think that the Raspberry Pi can do the compositing of the layers itself so that each of these streams could just render to a buffer, and then the Raspberry Pi will just put the buffers on screen in the correct position. But for the life of me, I have not been able to figure out how to work at a lower level. So there's something called a KMS sync. And if we, instead of the FB dev sync, we try to use the KMS sync, you'll see that it starts and then it just fails. It fails with an error saying that there's no space left on the device. And the reason for that is that for some reason, no matter what I try, the frame buffer insists on holding on to the KMS planes. And the planes are basically these hardware layers. And I can't figure out how to get that frame buffer to release them. At some point, I hope to figure this out. But no matter what I do, I've tried disabling the DSI screen. I've tried various config options. Nothing seems to allow me to access that KMS stuff directly. So we're going to keep using the frame buffer device for now. Now, I'm going to set up this video mixer. So we're going to do CPU video mixing. I think that this does it in the CPU, and we'll see if this Raspberry Pi can handle this and what the performance is like. So let's figure out that video sync. Okay, so we've got the pipeline script here, and when we run this, we should now have two syncs. Okay, it's starting, and let's see, what do we get on screen? Okay, great. So we have on screen, we have the video test source, and we have the RTSP stream. That's good. So that shows that we can have two simultaneous streams. I think the next thing we need to do here is resize this RTSP stream so that it's basically half the height, half the width. Let's just confirm what the size of the screen is. I believe it's FB set. Okay, so great. We can see this is our screen geometry, 1280 by 800. So effectively, okay, we're going to take this RTSP source, and instead of piping it to the mixer sink, we're actually going to scale it. So we're going to pipe it into video scale. Equals, yeah, 640 and by equals 400. Okay, so now this should rescale the RTSP stream to 1/4 of the screen size. Let's see what happens there. Okay, we're seeing, okay, great. Now it's appearing in the middle. Now the question is, why is that appearing in the middle? We did set the X position here to 0. Let's see if we can figure out what's going on there. Okay, I think I figured out what's going on here. So the video mixer appears to be centering whatever I give it in the middle of the screen. So I think the problem is that I'm just actually not giving it enough data. Let's actually create 4 sinks here. So we have 1, 2, 3, 4. The compositor is the newer way of doing mixing, and it differs a bit from the old video mixer element because apparently the old video mixer element would do a whole bunch of automatic transformations for you. I guess this compositor, you have to do everything yourself. You have to make sure that everything is correctly set up, the video formats are in the right format, etc. So what I discovered was that we have to specify this pixel aspect ratio. So if I run this without this, so basically this is the video conversion. I'll run this pipeline and you'll see that everything on this screen is actually skewed. Now, if we keep that pixel aspect ratio, let's rerun that pipeline. You'll see that now we get video in exactly the format that we expect. So again, this is just gstreamer complexity. You have to spend a lot of time reading through forum posts. There's a lot of very obscure random information about this library, and in the end it seems to be working. So we have 1, 2 streams, we have a video test source, and we have a blank here, which, why don't we fill that in right now? Let me just grab one more stream source. So let's duplicate this block. We're going to duplicate the block, we're going to put it in sink 3, and we'll move the test source to sink 4. Okay, so now we have what should be 3 streams. So we should have 1, 2, 3, and the test source here. And we do. Okay, great. So perfect. We have all of the video streams that we expect. They look pretty good too. I think the frame rate is pretty decent. Yeah. So okay, that's great. The only problem we seem to have right now is that we're occasionally getting weird errors, which suggest that there's some latency, there's, I guess, maybe some timing issues. So one of the things we do need to do here, we actually want to add some queuing in the pipeline. So basically, we just want to give gstreamer a chance to hold a little bit of a buffer at every stage so that we don't fall behind if the network gets slow or if the decoder gets slow or if anything just happens to fall a little bit behind. We want to make sure that we're always queuing throughout the pipeline. The other thing we want to do too is we actually want to turn off sync on the frame buffer device here, because we want the frame buffer to show frames as they arrive. We don't necessarily care if there's some jitter there at the very end. We don't care if the frames don't show up exactly at the right time. We don't want the frame buffer device to be holding onto frames because it's not the right time to display them, or dropping them because they're past their time. The frame buffer device should just display frames as it gets them and move on. So that's what we're going to set sync equals false there for that. And then what we're going to do here is just add some queuing basically between each step. I don't know what the right level of queuing is, but effectively what I've seen is just a recommendation that you insert a queue everywhere. So every single one of these should effectively queue. Unfortunately, there's not a lot of movement on the cameras right now, so I can't necessarily say for sure whether we're getting great frame rates. Maybe at some point there'll be a car passing by. We'll be able to see if things are happening in real time. So everything is actually working here. This is great. It looks fantastic. Honestly, the screen is beautiful. I'm very happy with how this turned out. I think what we need to do is try to polish this up a little. So we have a bash script, but that's not necessarily a nice, well-packaged solution. Let's see if we can maybe build an executable that can launch this, something a little more intelligent than just a straightforward script that is going to be a little bit brittle in general. So what I'm going to do, I'm going to reach for the programming language that I know the most right now, which is Rust. So let's see if we can build a little tiny Rust app that manages the same. Basically, let's see if we can build this gstreamer pipeline in the same way that this bash script is doing. Let's start here by creating a new Rust project. I'm going to leave this running in the background here because it's kind of cool to see. So let's start ourselves a new Rust project. Usually pretty easy. So I am using VS Code with a remote shell on the Pi. It's going to be a little bit slow at times. It took some time just to install the tool chain. It is surprisingly usable. I think it's written in Node.js, which, not the greatest if you want to run it on low-end machines, but surprisingly, the performance has been pretty good. It lags a little bit here and there, but it's nice to just develop directly on the Pi and not have to worry about developing on my MacBook and then transferring stuff over to the Pi, which it's possible, but it's still a pain in the butt. Let's start figuring out how to actually hook up a Rust project with gstreamer. Okay, first thing we need to do is figure out the correct crate for this. And I think I looked this up earlier. It seems like this is not doesn't seem like this is too complicated, but I'm pretty sure. I think it's literally just gstreamer. Yeah, so let's add this crate. Definitely don't want to be writing Rust code without Rust Analyzer. Okay, install that in the background. Okay, so this gstreamer crate seems pretty reasonable. Let's see if it even works. I'm hoping that there's not a complex build step. Actually, let's just go straight to docs.rs and find gstreamer. Actually, it looks pretty straightforward. Let me just make sure that we don't need any other dependencies here because they were mentioning glib, so I think most likely I'm going to need this glib crate as well. We do have to give the poor Raspberry Pi a small chance to catch up. It's currently in the middle of building all the proc macros and things for this. So to get gstreamer working, we need to add glib to cargo.toml. Then I head back to the playback tutorial to see if I can get something running. I take a look at how the tutorial sets up its elements, which is pretty close to the gstreamer CLI syntax, just more verbose. I wrote a quick test using video test source and FB dev sync, compile it and try to link it, but then I hit a runtime error. Nothing shows up. After a bit of digging, I realized that the issue is that the elements aren't linked properly. In gstreamer, I can't just create the elements, I also have to add them to a pipeline and explicitly call link on them. So I create a new pipeline, add both elements to it, then I call video test source link, and after that, I set the pipeline state to playing, and now everything works. Video shows up on the frame buffer as expected. Aha, there we go. Okay, so that's all we needed. We needed to create this pipeline, and once we created the pipeline, everything runs from there. Okay, this should make life a lot easier. Let's see what we can do here. I should be able to, there was a way to parse pipelines. Let's see if we can just pick up, yeah, here we go. So you can just gst parse launch. Okay, so let's create a new function, stream RTSP, and we'll just take the URL as a string. I'm not sure what this is going to return just yet, so let's just take a moment to grab this. I'm building a reusable function that sets up a mini gstreamer pipeline to handle RTSP decoding. It takes a stream URL, decodes it, and then connects the output to a sink. That sink is exposed as a ghost pad, which is basically a proxy that lets us treat a bin like it has its own input or output pad. That way, the whole thing behaves like a single element, making it easy to plug in wherever I need RTSP input. Now, with luck, yeah, there we go. Okay, so now we have a stream working as we expect. A little more complicated than I hoped, but this function gives us a nice reusable way to create a stream. So now we should be able to automate the frame buffer part of things and create all the sinks, which we can then redirect all of these individual RTSP streams to. So let's see if we can do that as well. The pipeline syntax is surprisingly flexible. It does a lot for you. What you have to do, if you're building reusable pipelines, you have to use something called a bin rather than an element. And a bin just lets you assign these things called ghost pads, which effectively it allows you to make almost a virtual element, which you can then plug into any pipeline. So you can create source and sink. I think that means you could effectively create your own reusable building blocks. But to create these takes a little bit of overhead. So when we actually make this compositor, we're actually going to create a bunch of pads on it, which are effectively its inputs. And we're calling these the sync 0 through sync 3. And we're setting the property of these pads so that the compositor knows where and like how big and what location on the screen each one should live at. Oh, okay. Okay, so this took quite a while to figure out. GStreamer is very weird about these pads that connect all the elements in the pipeline. And apparently when you are creating a compositor, you need to set the compositor pad properties after you actually link with another part of the hierarchy. So basically what I just had to do is refactor the code so that when we create the compositor pipeline internally, we just return all the internal pads so that we can actually set those properties after we link. It's a little bit awkward, but it's not going to be a huge deal. So, okay, so now we basically have Rust code that can show 2 simultaneous streams. We should be able to scale this up to 4 streams really quickly here. I'll just go through and do that, and hopefully we'll have a little binary that we can execute and just generate all of this for us and have a nice self-contained binary, and we'll see what else we can add to this thing to make it a little more usable. So let me get right to that and I'll start coding up the stream links. Okay, so after fighting this a little bit, I think I understand what my problem. Well, there were quite a few problems here. The first is that pads are really weird in GStreamer, but as you can see, we've actually got it all working together nicely. The other thing is that the GStreamer pipeline syntax is way more powerful. It does a lot of things automatically that if you're trying to build these things by hand, you lose out on. And apparently one of the things is that if you have a compositor, if you're creating these pads, and you fail to actually provide any data to that compositor, the compositor is not very happy about it. And I actually had to add all of my sources before this compositor would actually activate. So now I have 1, 2, 3 RTSP streams and 1 test pattern in the bottom corner here. So everything's working now. I'll have to clean up this code a little bit to make it a little more reasonable, but yeah, so we have a full executable we're building. We have basically a Rust executable that builds a GStreamer pipeline that gives us a UniFi camera here, UniFi display here. So I'm going to take a little break here. I've been working on this for a couple hours now, and fighting GStreamer has definitely taken quite a bit of work. I guess what we'll do next is just try and figure out a good way to configure this. So number one, we want this executable to boot up every time that this device boots up. And we don't want to boot into the graphical interface. We want to boot directly into this interface. And for now, we have 4 working panels. Honestly, it looks really great. The frame rate is good. I can see it doesn't look choppy at all. You can actually see some motion in the trees here. So I don't know exactly what frame rate I'm getting, but as the wind is blowing the trees around, we're seeing things moving reasonably well. There's probably a little bit that I could do, maybe scaling these videos or possibly putting some borders between them. Obviously this blank spot here, I'm going to have to find a purpose for this panel. There's another camera I haven't hooked up yet, a little tiny portable camera, Wi-Fi only. Might do that one as well. Let's take a break from this for a bit. We'll put the final finishing touches on this at a later time, hopefully not too long from now. All right, it's about an hour later, and I think it's time to wrap the project up for tonight. So there's a few things left. I want to get this thing booting up directly to this camera view from a clean boot. So we're going to do a little bit of systemd configuration here, which should allow us to basically boot this thing directly into the mode that we want exactly. Now, the systemd part of this project was probably the most frustrating. The setup itself was simple enough, but the documentation is murky, especially if you're not deep into systemd like I am. I created two units, one that runs as early as possible to unbind the text console and display an image on the frame buffer, and another that starts the cameras once the network is online. In the end, I also added a kernel parameter fbcon equals map:2 and remove splash from the kernel command line, and that fully disables the frame buffer console because I just couldn't find any better way to silence systemd's boot messages. Okay, backlight seems to have come on this time. Okay, we have a splash screen. And in a moment, we have cameras. Great. Okay, so the boot is still pretty slow, but at least now there's nothing on the screen. There's no Linux kernel boot up messages. It just goes from splash screen to cameras active. Hey there, this is Matt from the future. I have something pretty cool to show you. I managed to get the boot screen working on this in initramfs. And that means that this thing is going to show images basically from the time it starts booting. The first thing it does is start to show this cute little pixel art that I whipped up. And it shows this during the boot process, and it doesn't show any other boot messages until the time when it's actually ready to boot up the camera view. From the second this thing boots, you see nothing except what I designed it for. So it kind of gives it a nice little appliance look that makes the whole project feel a little more polished. Unfortunately, my doorbell camera from UniFi actually decided to completely die. This thing is totally brick, doesn't respond at all. So you'll notice that there's a little tiny blank spot on this screen here where that camera should go. Thanks to everyone who's come out and watched the last couple of videos. If you could help the channel by liking and subscribing and all that other YouTube stuff, that would be great. It should help the algorithm promote some of these videos in front of people who might not normally get them. Anyways, that's it for now. Thanks for watching. See you next time.